Good afternoon, everyone. Welcome and thank you so much for joining us. You have now joined the 2021 Virtual Nobel Inspired Lecture. Just checking if everyone is on screen. I don't seem to be on the main screen at the moment. But in the meantime, my name is Naledi Moleo. I'll be moderating this very important webinar. If someone can signal to me if you're able to hear and see me, just so that we are able to go ahead. Okay, we're good. Thank you so much for joining us once again. My name is Naledi Moleo. I'll be with you until 3:30 as we have this critical discussion. This Nobel-Inspired Lecture, the theme for this afternoon is Adapting to Climate Change. What does the science say? I want to talk a little bit about why this is such a critical discussion, not just in our generation, but especially at the time that we're living in with the pandemic that the world is dealing with. There is a lot of concern that the world is afraid of the pandemic in COVID-19, but we're forgetting that we're facing another defining crisis for our generation, and that is the crisis of climate change. We've seen the effects of it. It is no longer a myth that sits in the back of our policymakers' minds. It is about time that it comes to the fore of the discussions that we have, not just as South Africa or as Sweden, but as a globe as a whole. I want to talk a little bit about some of those effects that we have seen that have cost us very dearly. If you look just in Central America, we've seen the dry corridor that has brought great devastation. We've seen floods in South Asia. We've seen droughts in East Africa. And then, of course, as you come closer to home here in South Africa, we know that Southern Africa is still dealing and reeling from the effects of Cyclone Idai and Kenneth. All of these things are the after effects of climate change and what it is doing to our globe. All of these effects have not only cost us lives, agriculture, and crops, but they've had massive economic impact as well. And they've stopped the way that some of us are able to put food on our tables. And the sooner we deal with understanding climate change, and of course the policy decisions that need to be made, the sooner we're able to get on a better trajectory. So we have a wonderful discussion today. Of course, this lecture is brought to you as a partnership between the National Research Foundation and the Embassy of Sweden in Pretoria. And an interesting time that this is taking place as well, because it takes place at the same time as we see the announcement of the 2021 Nobel laureates, specifically those that were given that prize in the department or category of physics that have done amazing work in the space of understanding climate change on the globe. We are, of course, broadcasting this webinar live on Facebook. That's the two Facebook pages of the National Research Foundation, as well as the Swedish Embassy. And of course, those webinars or these discussions will stay up on both Facebook pages. Feel free to use those pages to send some of your questions or your thoughts. And of course, feel free to do so on the Zoom line as well. Use the chat line. We're going to have two amazing lectures today that are going to be shared. We're going to understand the science behind climate change. We'll hear from Professor Francois Engelbrach, a professor of climatology at the WITS Global Change Institute. And we'll also hear from Professor Victor Gallas, an associate professor in political science and deputy director of the Stockholm Resilience Center, also program director of the Bejer Institute of Governance, Technology and Complexity. But before we get into those critical lectures, let's open the dialogue up with some words of support. And I will welcome first and foremost the Deputy Ambassador of Sweden, who joins us right now. That, of course, is Deputy Ambassador Ms. Ami Larsen. Jane, I hand the floor over to you.
Thank you so much. And it's a pleasure for me to welcome you all to this afternoon's Nobel-Inspired Lecture from the Swedish Embassy. Let me start by thanking all those who are involved in this year's second Nobel-Inspired Lecture, our collaborative partners from the National Research Foundation with Group Executive Dr. Beverly Damons, our two keynote speakers, Professor Francois Engelbrach and Professor Victor Gallas, and our eminent moderator, Mr. Naledi Moleo. I'm very pleased that we have been able to organize a lecture on one of the most critical challenges confronting all of us, climate change. The timing of today's lecture, as Naledi said, coincides with the Nobel Prize in Physics being awarded to scientists who lay the foundation of our knowledge of the Earth's climate and how humanity influences it. The Nobel Prizes are among the world's most prestigious awards, and from a Swedish perspective, we view them and the internationalism and excellence that they represent as part of our national identity. The joint Nobel-Inspired Lectures showcase research excellence and emphasizes the importance of research, technology, and innovation in addressing real challenges that confront communities. It also exemplifies the strong relations that exist between Sweden and South Africa. But as much as Nobel is a celebration of excellence of individuals and their beneficial impact on the globe, it is also an opportunity to inspire the next generation of scientists and creative innovators in South Africa and Sweden in the spirit of Alfred Nobel. In less than 3 weeks, negotiations will begin at the UN Climate Change Conference in Glasgow. The conference is taking place at a critical time in world history. We're in the midst of a climate crisis where catastrophes such as protracted droughts, violent fires, and devastating floods are becoming more common. The world's poorest are the least to blame for climate change, but they are hit the hardest by its consequences. All countries must reduce their climate impact to achieve the goals of the Paris Agreement, but the richer countries have a special responsibility to take the lead and contribute to the developing countries' climate transition. Sweden continues to take responsibility, and the government intends to double Swedish climate aid to 15 billion kronor by 2025, which is approximately 26 billion rand. Swedish climate aid contributes to important investments in both reduced emissions and more climate-friendly and resilient societies in poorer parts of the world. Sweden's increased climate aid also increases pressure on other rich countries to help fulfill the promise from 2009 of achieving $100 billion per year in climate finance. More countries increasing their climate aid would improve the chances of achieving real results in the climate negotiations in Glasgow, and thus increasing the pace of global climate transition. Our actions must be guided by science, and I'm therefore particularly excited and honored to have two such prominent climate researchers from South Africa and Sweden with us today, who will guide us through the latest science on climate change. And with that, I would like to wish everybody a warm welcome, and I look forward to an insightful dialogue about climate change and what the science says about the critically urgent situation we're facing. Back to you, Naledi.
Well, thank you so much, Deputy Ambassador, for those words of support. One of my greatest prides during the pandemic has been the work that has been done by South African researchers, and I hope that Dr. Beverly de Mons will be able to share that with us as well. She, of course, is Group Executive of the National Research Foundation. Dr. de Mons, the floor is yours.
Thank you. Deputy Ambassador Emmy Larsen-Jane of the Embassy of Sweden, Professor Francois Engelbrach, who has joined us, Professor Victor Gallas, Naledi, Malaya, ladies and gentlemen, a warm welcome to you all, and good afternoon or greetings wherever you are joining us from around the world. Thank you all for joining us for this, our second lecture this week in our Nobel-Inspired Lecture series. I think, as we've just heard, it's so opportune that we have this lecture series when we announce Nobel Lectures Physics today, but also in the week as we count down towards COP26, where we are looking to continue to engage on how we're going to avert the global climate catastrophe our planet faces. I think another thing that's very important is that both topics that we are covering this week could be noted as defining crisis of our time. We heard on Tuesday, when we looked at a year down the line, living with the COVID-19 pandemic, and what are its global effects. And today, to listen to the science of climate change and to maybe get a sense how interlocked all of these things are, that climate change and the pandemic themselves are not in isolation, but that the global impacts of these major crises affect all and sundry. And we heard on Tuesday just how even though we look at COVID-19 as a viral infection, the major felt impacts that we have, besides those of the infection, are also effects on poverty and hunger, and political instability and disparities of race and gender, and vaccine access. And we look, I'm sure, at this great collection of leaders of the world at the end of the month in Stockholm. And no doubt we will speak about the science, but we'll be mostly concerned about its effects on the here and now and into the future. So a special word of thanks goes to our distinguished panelists, Professors Engelbrach and Gelach, for accepting our invitation. We are a national research foundation. We fund excellent research, and we are proud of our science system and the research that it produces. And we will be led by the evidence of the science this afternoon and the engagement with our. And so we do want to say thank you to them for joining us. And so helping us to listen and to engage on what the climate science says. Deputy Ambassador, thank you for your continued partnership between our two organizations. And right now I give the floor to the science experts as we listen and be ready to engage. Thank you very much.
Thank you so much, Dr. Demons. And let's do just that. Remember, of course, after those two lectures have been delivered, we will be taking questions from the room. And of course, if you are on social media, so be part of the discussion. Don't just be a spectator, but be part of that discussion as well. Share your thoughts and your questions. Well, we're going to have our first lecture delivered now by Professor Francois Engelbrach. He's a professor of climatology at the Wits Global Change Institute that's affiliated to the School of Geography, Archaeology and Environmental Studies. Professor Engelbrach is one of the most distinguished international climate change experts, specializing in the projection of future climate change in Africa. Professor Engelbrach, the floor is yours.
Thank you so much, Naledi, for your very kind introduction. And I also acknowledge the very true words spoken by Deputy Ambassador Jane and also Dr. De Monte. It's a privilege for me to, of course, present in this specific edition of the Nobel Lectures. So let me share my screen, and then I will start immediately. Okay, we have a slight technical problem, but it will be resolved soon.
Let us know if you need any help, Prof. Your mic is off, Prof.
There we are. Now you can hear me, I trust. And Naledi, I can see you are confirming. You see the slides, right? Okay, thank you. Sorry, everybody. So I would like to talk today specifically about Southern Africa as a so-called climate change hotspot. Within the context of our theme of discussion today, namely climate change adaptation. And I want to point out today that there are in fact limits to climate change adaptation, which greatly enhances the importance of climate change mitigation. But let me systematically show you what I mean. And I will start by pointing out that Assessment Report 6, Working Group 1 report of IPCC has, of course, been very widely distributed and talked about since its release in early August this year. And now, of course, the climate change discussion is going on in full force towards the 26th Conference of the Parties. Now, shortly after the release of the report, it was called a Code Red for Humanity by the United Nations Secretary General. And that is really how the report is now known. It is now regarded as science giving this important warning to the human race towards this most important conference of the Conference of the Parties meeting we've probably had to date. After all these years, I almost want to say decades of climate change negotiations. And why is that the case? It's because Earth is warming faster than we previously thought. And as a result, the window is now closing for avoiding the most catastrophic outcomes of climate change. And of course, around the release of the report, a number of these extreme events that Naledi referred to occurred. For example, in this slide, you can see some of those devastating fires that occurred in the Mediterranean and also in California around the time of the release of the report. Also right now here in Southern Africa, there's of course a devastating drought too few people know about, namely the drought in southern Mozambique, that is threatening the livelihoods of more than 1 million people, and in fact is already causing famine in some communities. So nowadays when people turn on their televisions, they see evidence of climate change. They see unprecedented events they've never experienced in their lifetimes. And I think, of course, in combination with the science, the evidence has become overwhelming and is now generally accepted, including by all governments, through the Paris Agreement on climate change, that we as humans, we are the cause of climate change and global warming. So I also want to acknowledge this important recognition given to some of the world's pioneering climate modelers through the Nobel Prize in Physics being awarded, as we've also just heard from the Deputy Ambassador, to two of the world's prominent pioneering climate modelers, Professors Manabe and Hazelman. And in the early 1960s and 1970s, they laid the important foundations of what has now become the science of projecting future climate change. But this is an important further step taken by Sweden through these awards. I know the awards are of course, not routed in politics or the important issues of our time, but in science. But it comes at exactly the right time, because it is a further message that the science of climate modeling and the science of projecting future climate change is solid science that should give us confidence in making the right decisions today. So in this talk, I'm now going to give a brief overview of these key findings of the IPCC Assessment Report 6 in the context of Southern African implications. The report, as many of you will know, is a collaboration amongst many scientists from so many countries. In this case, 234 climate scientists collaborated for about 3 years to summarize and assess the latest climate science of the last 8 years or so since the last big assessment. And the big question now is whether this awareness that I think now exists across the world in terms of future climate change impacts, will it lead to action? Will we, for the first time, really see a Conference of the Parties meeting since the Paris Agreement becoming an implementing meeting for the climate action that we need? So what I'll talk about now, I'll just briefly give some of the important global highlights of this report. Then I'll talk about implications for Africa and Southern Africa. And along the way, I'll also talk about something very important in the context of adaptation, namely global and regional tipping points in the climate system. So this is the type of graph many of you may have seen in the past. This comes straight from the summary of policymakers of this Assessment Report 6. On the left-hand side, you can see future levels of global warming that will be reached and exceeded depending on the climate change mitigation scenario. Now, in this specific case, we are looking here at the top right-hand side, for example, at a low mitigation future. This is a future where the world's future economic growth continues to be fueled by fossil fuels. And you can see we are reaching levels of global warming close to 5 degrees Celsius towards the end of the century. On the other hand, the report considers...
Can you hear me, Prof? Apologies for that. I'm just getting a few notes. Could you please try and move your screen, not from the presenter's view, but to the display view, because we seem to be seeing all your notes as well on your upcoming slides.
So I do not have any notes on my slides. I'm not sure what you are referring to. If you're seeing these words here, yeah?
We can see the next slides. It's not, I don't think it's too much.
I see.
But it shouldn't, as long as it doesn't...
So let me just make an attempt to do that. I'm not sure. I think I should maybe maybe this has solved the problem. Naledi, is this better?
No, it looks the same, but I think it's not a train smash, Prof, because we can see everything clearly.
Sure. Yeah, my apologies for that. Okay, yeah, unfortunately, I'm not sure exactly how to solve that. So, yes, so the first important finding then from this report is that global warming has now reached a level of 1.1 degrees Celsius. That's the best estimate we have available right now. And that means we are close towards exceeding the 2 thresholds of global warming that are dangerous according to science, namely 1.5 and 2 degrees Celsius of global warming. I'll soon explain why those thresholds are thought to be dangerous. Now, the second important finding is that even under these best effort mitigation futures, the chances are now, it is now more likely than not that we will exceed the 1.5 degrees Celsius level of global warming. And we will exceed it in the early 2030s. That's the best estimate for exceedance. So that's already a startling finding. It is probably already too late to avoid exceeding one of the most critical thresholds of global warming. Let me explain a little bit more how this works. So on this slide, we are looking at climate change mitigation scenarios as used by the report. So the line in dark red refers to a low mitigation future, SSP 8.5 as it's known in the report. And you can see in this specific graphic that carbon dioxide concentrations continue to increase, while emissions continue to increase into the atmosphere in the coming decades. So this is a fossil fuel future. And then on the other side of this spectrum, we have the very strong and very high mitigation scenario. So in this strongest mitigation scenario considered in the report, we achieve carbon neutrality in the middle of the century, and emissions are cut rapidly and immediately over the next 10 years, roughly halving emissions by 2030. All of us will immediately realize what an immense challenge that is. Even if we do all of this, the chances are greater than they are not that we will exceed 1.5 degrees Celsius of global warming. But on the positive side, the chances are excellent. Precipitation over the land masses, the projections are very clear that precipitation will be increasing, and this can already be seen on the average over the world's land masses. I'll soon explain why parts of Africa is a big exception in this regard. Arctic sea ice, that precious ecosystem, is projected to disappear completely in the Northern Hemisphere late summers around mid-century for low mitigation futures. And then, of course, of immediate impact, sea level rise. Sea level rise it can still be restricted to below 0.5 meter in the presence of strong mitigation, but in the absence of strong mitigation, it will approach 1 meter towards the end of the century, displacing hundreds of millions of people if we only look at today's population from the low-lying coastal parts of the world. And then there is the possibility of global tipping points being reached. So in this regard, I would first like to point out that somewhere between 1.5 and 2 degrees Celsius of global warming, we may reach that critical tipping point where the Greenland ice sheet becomes irreversibly unstable and eventually collapses and disappears completely. Now that will take millennia to complete as far as current science can tell us. The other problem is that the West Antarctic ice sheet, although it is less understood, it's also possible that its critical tipping point is somewhere between 1.5 and 2 degrees Celsius of global warming. Now in these two ice sheets, we have 12 meters of potential sea level rise. And the current assessment of the report is that under sustained warming of 2 degrees Celsius of global warming, sea level rise may reach levels as high as 6 meters over the next 2,000 years. 2,000 years, of course, feels far away in the lifetime of humans, but remember, this means that our generation is physically altering the coastline of the planet for future generations. Effectively, we are removing living space from the planet for future generations. And of course, the impacts will be far-reaching, as I've already mentioned, in terms of displacements in our own lifetimes and in this century. And now, towards the last part of my talk, I would like to bring the message home to Africa. Now, in the report, you will see that climate change is assessed in great detail for all regions of the world. And it starts with maps like these, that for a given level of global warming gives a projection of how temperature patterns will change for different parts of the world. Now, the important message that we can see in this very first slide, 1.5 degrees Celsius of global warming, is that in the southern hemisphere, the southern land masses warm up faster, of course, than the global average temperature. And the location in the southern hemisphere with the highest projected increase in temperature and also the highest observed increase in temperature to date is nowhere else but in South Africa's neighboring country, Botswana. And that has everything to do with the regional climate system of Southern Africa in the subtropics. As global warming, or should global warming reach values of 3 to 4 degrees Celsius, then temperature change in Southern Africa becomes catastrophic. There's no other word. In this case, the regional temperature increase becomes in the order of 6 degrees Celsius. And back in 2018, the IPCC in its special report concluded that this will imply the likely collapse of the maize crop, the staple food of Southern Africa, and the cattle industry across Southern Africa. So that is a Southern Africa which will be a different world than the world we know today. This is also partially because of the fact that this region is not only projected to become drastically warmer, it's also projected to become generally drier. And that combination of a region that Southern Africans will know that is already warm and dry and water stressed, now becoming drastically warmer and generally drier, that greatly limits the options that we have for adaptation. And in the report, there's also a great deal of material and assessment being provided in terms of why these changes are projected. For example, in Southern Africa, the reason why winter rainfall is decreasing along the Cape South Coast, and many of you will know about the Cape Town drought, is because of the fact that in a warmer world, frontal weather system, so-called storm tracks in the Southern Ocean, are increasingly being displaced towards the South Pole. So the last few slides are the conclusions. I would like to conclude by mentioning to yourselves, mentioning to the audience today what I think the 4 biggest risks are that Southern Africans need to plan for in terms of adaptation and in terms of trying to avoid these through contributing fairly towards climate change mitigation. I think the single biggest risk that South Africa faces today is the possibility of a day zero drought in the Gauteng province, occurring not in the far future, but in the next 10 years or in the next 20 years. We know that our city of Cape Town has come close to this. It can also happen in Gauteng. And then I'll also just briefly show a few pictures about the impacts of droughts in the region, heat waves impacting directly on human health, and the possibility of stronger tropical cyclones than we've ever experienced before. I'll just spend 2 minutes more, and that will be it from my side. Firstly, Gauteng Day Zero drought. Let's be realistic about this, everybody. The hard reality is that this is already a risk. It can already happen. Back in the big El Nino drought of September 2016, right at its end, the level of the Vaal Dam was below 25%. South Africans will know that if that dam's level should fall to below 20%, the supply to the Gauteng province is immediately severely compromised because of water quality issues and because of the fact that it's difficult to pump the water uphill to the Gauteng province. In a warmer world, with the region becoming systematically drier, this risk is increasing. Just think about the economic impact in South Africa. So that's why I'm thinking this is our #1 risk. I've already spoken about the fact that should we reach 3 degrees of global warming in this century, current climate science tells us that it's likely the end of our maize crop and our cattle industry. That's just from biophysical implications being considered. What about the socioeconomics of farming? What about subsistence farmers? How many multi-year droughts can they ride out before they have to give up how they've been living their lives and move to one of the big African cities? So if we take into account socioeconomics, this threshold of collapse of aspects of our agriculture is probably in the region of 2 to 2.5 degrees Celsius, not at 3 degrees Celsius. Heat waves. This report from IPCC is clear that the next 20 years will bring unprecedented heat waves to Southern Africa. Now, heat waves can impact directly on human health and mortality, as we've seen with the heat wave in the Pacific Northwest. In Southern Africa's informal settlements, people don't have air conditioning. They often don't have easy access to cool water. And climate and health experts will tell you immediately, this is literally life-threatening. And the heat waves of the next 20 years will be of a magnitude we've never seen before in Southern Africa. Finally, tropical cyclone Idai, mentioned by Naledi right at the beginning of our interaction today. All I would like to say, it's the biggest tropical cyclone in terms of losses induced, including losses in human lives, in the history of Africa, south of the equator. More than 1,300 people lost their lives. Unfortunately, this report is clear that in a warmer world, the risk of these, as they would be called in the North Atlantic Ocean, Category 4 and Category 5 hurricanes, reaching Maputo or Richards Bay exists for the first time. It has never happened before that such an intense system has moved that far south. Now that risk exists. So to conclude my last slide, it's easy to become extremely concerned, and despair is not unheard of course, when people are confronted by these risks, maybe for the first time. So how do we cope and how do we move forward in terms of the important guidance that climate change science gives us in terms of these risks? Firstly, we need to acknowledge that we are committed to further warming. So the world is going to warm further, at best to somewhere between 1.5 and 2 degrees Celsius of global warming. There will be further impacts, but climate change science gives us an indication of what those impacts will be. And that gives us the ability to adapt, at least to some extent, to what is coming. Certain tipping points may, however, be reached, globally and regionally, where it is too late, and we will have to face with a new regional environment or with a new global environment, for example, systematically and irreversibly losing the Greenland ice sheet, or an environment where for the first time, the Gauteng province of South Africa runs out of water, where the eastern mega dams cannot supply the Gauteng province with the water it needs for its continued development. So there are limits to adaptation. And therefore, we need also to contribute fairly across the developing world to climate change mitigation. Of course, mitigation needs to be led and will only be strong and successful if it is led and to a large extent funded by the developed world. All these issues will, of course, be part and parcel of the upcoming COP26 negotiations. In the end, what I would like to conclude with is that as we are meeting here today, humanity still has in its hands what the level of global warming going to be. If we cannot restrict global warming to 1.5 degrees Celsius, let's restrict it to below 2 degrees Celsius. And we will avoid a vast range of negative impacts across the world, including in Southern Africa. So despite these hard realities to face, everybody, as in 2018, when this special report was released by IPCC, also today in 2021, as we are heading towards COP26, there are still a lot of reasons for hope. And let's hope that these reasons for hope will bring some fruit at the upcoming 26th conference of the parties. And with that, Naledi, I hand the floor back to you.
Professor Francois Engelbrach, thank you so much for that presentation. I want to say thank you because it was so detailed and so enlightening, but I must tell you, it's also scared the living daylights out of me, honestly. It was a difficult presentation to hear, especially because you're able to already see some of the signs of what you're talking about as that worst case scenario. In the news, we're covering the water shortages already in Gauteng, and the picture you paint looks even bleaker. Then the question becomes, what do we do, right? We've seen the young activists across the world saying, well, it's about policy, it's about investing and really starting to turn things around because of, as you said, the window is closing for us to avoid catastrophic outcomes. Professor Victor Gallas will hopefully answer that question of how we actually start to turn things around. Professor Gallas is Associate Professor in Political Science. He's Deputy Director of the Stockholm Resilience Center and Program Director of the Beijing Institute for Governance, Technology and Complexity, that program there. But he will be able to talk to us about the interplay between financial systems, the Earth system dynamics, and also the wonderful opportunities that are available to us in new technologies. Professor Gallas, the floor is yours.
Thank you so much for that kind introduction, and thank you so much for inviting me to contribute to this very important event. I'll start sharing my screen, hopefully without any hiccups. There you go. You seeing it, right? Excellent, thank you. So I would like to go back to something that Dr. Damons has said even in the opening of this talk, the fact that the climate crisis and the pandemic are quite difficult to separate from. It's unavoidable that we discuss both of these issues at the same time. I'm just sharing this image. It's from The Guardian. It's from a big Congress center in Madrid in March 2020. As you can see, you see temporary hospital beds due to the pandemic. This was actually the same location where the COP25 negotiations took place. And this, I think this is a scary illustration of how close the pandemic and the climate crisis are connected. And I want to talk about both of these. So whenever we talk about adapting to climate change, I think we need to talk about how do we adapt to a new planetary reality where climate change, extreme weather events, and new diseases might be part of that new reality. To me, that is key to understand these two at the same time. Connected to the pandemic, I mean, many of us noted, it was noted in international media, of course, through all the lockdowns, end of travel, etc., that CO2 emissions just dropped very, very quickly during the pandemic. And of course, there were early discussions on how would this have an impact on the climate system? Would this actually be an opportunity to tackle climate change in new ways? A little bit of a reality check. Again, ahead of COP26 coming up, what did actually happen? And what does it tell us about the capacity of governments and societies to adapt to a shock and come out and bounce back from it? We knew from the beginning that big economic slowdowns tend to make a dent in emissions. We've seen that before. This is from an article from 2012, that every time we move into a big global economic crisis, carbon emissions go down. But we also know, and we noted that from the last financial economic crisis in 2009, that actually you do see a decrease in emissions, but once economies bounce back, you go back to the same trajectory as before. And the hope was for for a long time during this pandemic that we would avoid that scenario of bouncing back to what was before in terms of emissions. The problem is, of course, this is exactly what we're seeing now. This came out just recently, the International Energy Agency. If anyone is interested in getting the latest numbers on energy consumption, carbon emissions, and what we need to do, I would recommend you to look at this report. We're seeing the second largest global carbon emission jump in history and a large rebound in coal and oil use. We didn't manage to actually use this opportunity to transition into a more stable climate system. The impacts of that drop of carbon emissions is so small on the climate system. It's barely measurable. So these are numbers from last year. A cooling of around 0.01 plus minus 0.005 degrees Celsius by 2030 compared to a baseline scenario. Minimal impacts on the climate system. And that is just an observation based on the fact that we've emitted so much carbon already that little dip will not have a big climate impact. The third observation ahead of COP26 again, and whenever we talk about adaptation to all these impacts that Professor Engelbrach has mentioned, the world's richest countries have not delivered on promises to fund climate action and adaptation in vulnerable countries. Not come up to those sums that have been promised for a long time ago. So a little bit of a reality check. We haven't learned a lot from the pandemic. We haven't been able to fund what we promised to fund to help countries adapt and transform their economies. Another aspect that I think is important whenever we talk about climate change, whenever we talk about adaptation, is that climate change is a symptom of changes we're doing on our living planet as a whole. So I mentioned the pandemic. We're in the middle of a pandemic. It's not only about COP26 that we're discussing in Glasgow, but also Conference of the Parties of the Convention of Biological Diversity that's happening as we speak now in China. So the future of biodiversity is being discussed now and is an equal important part of living on this planet as a species. The thing with pandemics and infectious disease, and I will mention that in my next slides, is that the fact that we're seeing these jumps of disease from an animal species to humans is related to environmental change. So that's just a reality. Whenever we talk about climate change and adapting to climate change, I just want to acknowledge another aspect that is part of the fact that we're changing the living planet, the biosphere, the world's oceans, the forests, savannas, landscapes, etc. These are so important to help us maintain a stable climate system. This is from a recent paper that came out from my colleagues is the fact that if we didn't have the biosphere, the parts of the living planet, we would already now be hitting the 1+5 degree target already now, because the living planet is already removing parts of the fossil fuel carbon that we're adding. So thanks to that, we're able to stay at a lower degree of warming. Without a stable biosphere, by 2050, we would be at plus 2.5 degrees. So way over the Paris target by 2050 if we didn't have ecosystems and forests and oceans that would help us remove that. So that, to me, this is so important to make sure that we not only talk about reducing carbon emissions from fossil fuels, but protect and steward nature. Going back to the connections between planetary change, so not just climate change, but planetary change and pandemics. We've known for a very long time in science that a new emerging disease could come around and have big impacts on the world. So these are just a couple of front pages from the Times. In 2003, we talked about SARS, if anyone remembers SARS. After that, we had bird flu in various dimensions. We had the swine flu pandemic, etc. What is important to remember is the fact that many of these diseases, called zoonotic diseases, are related to environmental change. The fact that some of these viruses manages to jump the species barrier is the result of the fact that we, or human activities, are decreasing natural habitats. We're deforesting, we're intensifying agriculture, we're overusing antibiotics, etc. And we know more or less, I mean, of course, these are all assessments, but just here on the left side, we know where in the world these diseases are likely to emerge. This is where you have rapid environmental change, you have rapid urbanization, rapid demographic change. And on the right side, you see a 100-page synthesis that was made just a couple of months ago to explore the connection between environmental change, such as land use change, and new emerging infectious diseases that lead to the pandemic. There's been a lot of interest around wet markets, for example, or bushmeat in the literature. But if you look at the data, and this is from an older article from 2008, but I think that the numbers still hold. And if you look at number of EID events, that means emerging infectious disease events, and you try to look back, what is it that causes these diseases to emerge and start to spread amongst humans? A majority of these events are linked to land use change or agriculture intensification. Of course, the fact that we travel, the fact that health systems in many countries are fragile, that means that you're not able to pick up these diseases early and respond to them in the proper way, etc. Things such as wet markets or bushmeat are actually not the main cause of global trends of emerging infectious diseases. It's human activities that are leading to this. So again, not just climate change, it's also planetary change and changes on the biosphere that are putting us in this very, very challenging situation that we are in right now. Another aspect of this question, so we had the pandemic, we're still living through an area of climate change with carbon emissions going up. Another part of this discussion is, of course, the economic packages for economic recovery. As you know, I think I'm sure you've discussed this a lot in South Africa. This is a big topic here in Sweden as well, and in general. Different countries have different capacities to invest, of course, in that economic recovery. There was a window of opportunity there to think through properly. How do we design these stimulus packages in a way that not only allows economies to bounce back and make sure that people have their jobs, but also contribute to a climate transition? The challenge, of course, is that at the moment, if we look at the numbers, again, that only 15% of these stimulus packages are actually contributing to a transition towards a safer climate future. And only 3% are directed towards the stewardship of the biosphere and nature. So again, this was a window of opportunity. There are many reasons why governments didn't manage to make that change, but just acknowledge the numbers and acknowledge the fact that we didn't manage to accelerate action in the way that we should have had. And that should be part of the conversation at Glasgow in end of October, beginning of November. So any good news? So sorry, it got a little bit negative here maybe. So I think I want to end on a positive note. I think there are two things that I want to mention specifically. And the first is that we've actually avoided very destructive climate futures. I want to mention that. And since this is a seminar in the spirit of the Nobel Prize, I want to say something about science and the role of science in supporting that transition. So the first point, one of the more optimistic observations that we should be making is the fact that we're phasing out coal globally much, much faster than we thought that we would be doing 10 years ago. So as you can see on the green lines, these green lines on top, assessments from the World Energy Organization where projections were that coal use would actually continue to go up. That was the assessment in 2013. That assessment has been decreased for every year that assessment has been redone. So coal use is going down. It should go down faster, but it's going down. So what that means in practice is that we're avoiding the worst case scenarios. I'm not saying that we're moving into a good scenario now, but we're actually managing to avoid the worst scenarios thanks to climate policy, international climate policy, and national climate policy. So we're avoiding those projections. We're no way close to the Paris Agreement at the moment. If you look at the current pledges that will be discussed in Glasgow, we're moving towards 2.6 degrees warming by 2100. The optimistic take on this is that actually we know that tackling the climate challenge, both by reducing emissions and investing in adaptation, the benefits outweigh the costs. Every study shows that each investment in climate mitigation and climate adaptation has bigger benefits than costs. So for example, this is again an estimate from the International Energy Agency. A transition towards a net zero scenario would create 13 million new jobs in the economy, which would be excellent. And there are other benefits of climate adaptation, like better social security, better healthcare, greener cities, better food, etc. So we've avoided the worst outcomes, and actually the best outcomes are beneficial both from a social and economic point of view. And then the last point on the role of science, I think this beautiful piece in Science was published by Jane Lubchenco in 1998, where she argues that we are entering an era of global change, environmental change, climate change that is so rapid that science needs a new social contract with society. I'm just going to summarize it very briefly. I mean, the paper is much better than my summary, but 3 key points. First of all, science should focus on issues and challenges that matter to people. There needs to be a focus from science, a commitment from science to tackle urgent challenges. The other aspect is that we need to abandon disciplinary silos and the notion that human and environment are different things. We're all integrated and interacting in a way now that is becoming so clear now. There's no way you can just study society without studying climate, and you can't just study the climate system without understanding what's happening in society. And that will require innovation in science. I think we might need to engage and do science in a different way. And one interesting example, and I just want to highlight the work done by colleagues in South Africa at CST, the Center for Sustainability Transitions at Stellenbosch, that developed this book. It's open access, so you can find it and download it, that develops and explains frameworks and methods that allow us to understand this rapidly changing reality and allows us to unpack these issues across scientific disciplines. That to me is extremely important and the way we should go. And another aspect to it, again, to highlight collaborations that we have with colleagues in South Africa already now, the fact that education is not only something that we do with academic students, we do it in society, in collaboration with change agents in society. So this is one particular leadership program that we're running together with the Swedish Institute called Catalyzing Change, that focuses on public and civil sector innovation, because adapting to this new reality, tackling a much more challenging climate reality and planetary reality requires innovation. And this is, again, something that we are doing in close collaboration across Sweden and South Africa, but also academia to civil society and the public sector. And we need more of that. And I'm very excited to see that happening already now across Sweden and South Africa. I want to leave you with this last little quote by the Nobel Prize laureate Suki Manabe, and he was asked immediately, of course, like what would be your observation ahead of COP26 in Glasgow? And then he said, making climate policy is actually 1,000 times more difficult than making climate predictions. So climate policy is difficult, climate science is difficult, but actually doing robust climate policy and having an impact in society effectively is much more difficult. So maybe we would need actually a Nobel Prize for that kind of science action as well. Thank you.
Well, thank you so much, Professor Gelles. Climate policy is harder work than climate predictions. That certainly is a brand new challenge for some of the great minds that are possibly in the room. And we'll catch up with this lecture a little bit later on as well. Professor Victor Gelles there speaking to us. We really do appreciate both those lectures from our speakers. I am going to open up the floor to questions. We've got a few questions that have come in already for Professor Engelbrach, and as the questions come in as well for Victor Gelles, I think I'll start with one of our own, and I'm going to find the opportunities here. I'll admit I'm somewhat of an eternal optimist, and I like to talk a little bit about, where's the green shoots of hope. This collaboration, for instance, between the Swedish Embassy and South Africa, an important discussion at a critical time. Where do we have more and more of these sorts of opportunities for collaboration, perhaps even where it is exchange of policy, as we talked about as well, Professor Gelles, the difficulty in being able to write those policies. Prof, I'll give that question to you, Professor Gelles, to start with. Where are the opportunities for collaboration from the north to the south?
I mean, I would say that they're everywhere. I mean, we see it very clearly in academia. We see it very, very clearly in the youth movement. I think the youth movement has made a big difference for the way we discuss climate policy internationally and nationally. I see strong momentum in the finance sector, to be honest, and it's not because they suddenly realize climate change is an issue. It's because they see risks to their portfolio, and that incentive is very strong to act on, and so that's another potential big leverage for change. But then in the end, I mean, the question, how do you make a malfunctioning government act on the climate challenge? That the pressure would need to come from the bottom up. I mean, there's a lot the international community can do, but it needs to come from the bottom up.
It's interesting because one of the questions that we got as well from the attendees, from an anonymous attendee, was obviously the solution relies heavily on policy changes, but how do you convince heavily corrupt governments to make changes to address these issues? That's a very big question to answer. But I think you've given us somewhat of a response there, that it has to come from the bottom up with the noise that we make through civil society and those sort of sectors. Prof. Engelbrach, there's a question that came in a lot earlier for you. I'm going to read it out for you quickly, also from an anonymous attendee. It says, is there any research underway in South Africa into possibilities of the use of geoengineering to mitigate temperature rise due to greenhouse gases in the medium term, thinking specifically of the effect of deploying sulfur dioxide into the stratosphere on local climate?
They are. Thanks for this question, but we should not be distracted right now at this critical point in time by geoengineering methods, which are all still close to science fiction at this point in time in terms of their scalability. And it is also unknown what the side effects in the larger climate system will be. And of course, the cost is usually tremendous. So right now, we know exactly what the solution is to slow down global warming. and to avoid the most dangerous thresholds of global warming. And that is to immediately cut emissions of greenhouse gases drastically. With immediately, I mean now in the 2020s. The indication that science gives us is that we need to halve emissions. We need to get very close to halving the world's emissions by 2030, and then continue and phase out what remains by 2050. Remember, there's a remaining carbon budget we have available. If we are going to exceed that budget, we will exceed these dangerous thresholds of global warming. Now, in the meantime, I can refer the member of the audience who has asked this question to a section of chapter 4 of the recently published assessment report, Working Group 1 report from IPCC, which in fact makes an assessment of the available possibilities we do have of using geoengineering interventions into the future, what the current understanding is of each, including their potential side effects into the system. But let me just say very clearly that a great deal of science is still needed before we can even attempt or consider to deploy these measures at scale. I mean, at a global scale. For example, I think I'm just reading the question here. What the question suggests is, for example, the possibility of pumping or getting in some way large quantities of sulfates into the stratosphere, which would then reflect sunlight and thereby cooling the planet. Of course, there will be, firstly, responses in the climate system if such cooling can be achieved through sulfates being released into the stratosphere. But there are also impacts on the biosphere. Just think about, for example, of all the plants that depend on sunlight. So it is not trivial. None of these methods is currently available where they can be applied at scale. Their consequences and unintended negative impacts are not fully understood. So right now, the focus should be entirely with everything we have in terms of our current abilities to reduce very, very drastically greenhouse gas emissions over the next 10 years.
Yeah, thank you. Thank you for that, Professor Engelbrach. I think it's interesting that when you start hearing the different suggestions that are being thrown at the table, it certainly shows just how desperate humanity is to start finding those solutions and to do it quickly as well. I have one message that came in on the Q&A box that I have to read. It says, I'm not going to lie, it really made me uncomfortable to listen to these presentations, but it was necessary to hear. That was from Nolwandle Mate. That's an interesting question or comment, because it essentially says no one wants to feel powerless as we discuss climate change. And then there was a question that speaks directly to that. This one from Villanavo Kavangali from IUCN South Africa. That question is, with the observed and projected changes, are there any key messages that we need to send to our government leaders in terms of future developments? But also, what can we do to assist communities to adapt better? And I emphasize the communities part of that question as well, just so that there's some sense of power that each community has as well. I'll give that one to Professor Gallas.
I think there's a lot you can do, and I think a lot is being done already, but more could be done. I think the key message for me whenever I talk about this is that climate change is happening now. We can act on it, and acting on it will create multiple co-benefits for social well-being across many, many dimensions. So any investment in communities, in healthcare, social welfare, infrastructure are beneficial not only from a climate adaptation perspective, but from a human well-being perspective. And that should be the focus and emphasis on those co-benefits, and not look at climate adaptation as just a pure cost. It's not just a pure cost, it's an investment in future generations and the well-being of people. And of course, and you should design and think about programs that invest in that kind of thinking and projects, and not do it and allow local communities to identify what they see as projects that would be beneficial for them in the short and long term at the same time.
Sounds like active citizenry is what you're describing, essentially. We have a question that's coming from Johan Juester. It says, for Professor Engelbrach, from my understanding, there is a cooler solar cycle coming. What role does external factors like solar cycles play in climate change, and how do you measure it against the human impact?
Johan, the climate system contains, as you likely know, seeing the question you've asked, a great deal of natural variability. And in this part of the world, Southern Africa, people know very well about this variability. For example, farmers across Southern Africa are very much used to the El Nino, La Nina cycle of droughts and floods, and can cope to some extent for droughts. The problem is, of course, that climate change is causing systematic changes in this natural variability. And for the Southern African region, it means more frequent droughts, longer lasting droughts that are becoming increasingly difficult to cope with. The IPCC, for example, assesses in this report that such an increase in drought conditions can already be detected in Southern Africa. It's not also something of the far future, something that can already be detected, and it is projected to worsen these long-lasting droughts over the next 20 years, so the near term in the IPCC projections. So there are various factors that cause natural variability in the system. Some of them are internal, quite likely, such as the El Nino, La Nina cycle, and then there are some external forces. Now, the solar cycle, of which the most pronounced cycle is the so-called 11-year cycle, does result in Earth receiving for periods of roughly 11 years long, slightly more solar radiation than for the next 11 years that are typically on the average slicing, a little bit more, a little bit less for these 11-year periods. And there are some indications that it does affect climate variability. So there are, for example, some credible papers linking the solar cycle to, for example, periods of more frequent El Nino or La Nina events. So there is an effect in the climate system, but to no extent that that effect is substantial in the sense that it can in any way save us, if I can put it like that, from the impacts of continued global warming over the next 20 years. So the effect of greenhouse gases in terms of warming the climate system, then causing drastic warming in some parts of the world, such as the Arctic and Southern Africa, far greater than the global average. And then in combination, in the case of the Southern African region, making the Southern African region is by far the dominant forcing. And natural variability, of course, can maybe bring us brief spells of good rains, but it cannot turn around the fact that the long-term trend is towards a generally drier climate. There is no expectation to think that the solar cycle will change to such an extent that it can really help us out of these great climate change risks we are to face increasingly in Southern Africa. And of course, the solar cycle can also not explain the warming that has occurred to date and climate change that has occurred to date. So it's there, it may have an effect. Natural variability is important, but in the Southern African region, the most important change of the next 20 years is the warming and drying that is likely to occur as a consequence of the world getting warmer and warmer.
We've got quite a few comments coming in, so I'm going to try and work through these as fast as possible, which is wonderful, and keep them coming in, because essentially everyone is going to come in from their perspective and try and get answers or also contribute to a discussion that needs to happen. Professor Gallas, you talked about the economic impact, and I have to say this just for myself. I think it's critical that we have the discussion around the economic impact of climate change, especially for policymakers and governments and business. If you say to them, well, this is a matter that impacts your bottom line, you tend to get their attention a little bit better when you do that. And then, of course, from an economic point of view, we get this question from Tumelo Mangena, who I hope we're seeing opportunity. Tumelo Mangena says, a great lecture from our two speakers. But here's my question. Do climate change investigation groups advise infrastructure organizations to take into account possible future effects caused by climate change in the way that they're doing their jobs, like building houses with stronger foundations or standardizing installation of air conditionings, etc.? Prof. Gallas, I'm going to give that one to you. I'm hoping this is opportunity that we're seeing here for investors and infrastructure groups.
I mean, it's a big question, and I can't answer for all infrastructure companies and all infrastructure development. But I mean, one thing that we should be able to say, at least, and I think Professor Engelbrach would agree, is that the estimates of how climate change will have impacts on infrastructure are getting better and better over time. And I think one of the game-changing aspects of the latest IPCC report is something called attribution science. So the fact that you can attribute extreme weather events to climate change much more directly than you could 5 to 10 years ago. And I think that could be a game changer for policy and economic actors, because suddenly it becomes very clear this extreme drought, this flood, etc., is linked to climate change. So climate change becomes a reality. And then suddenly you look into the future and think, okay, the future is changing and we need to act on that, both adapt and minimize risk. So attribution science in the climate sciences is a potential game changer for action, not just for the sake of the science. I don't know whether Professor Engelbrach would agree on that.
Prof, would you like to come in? Professor Engelbrach?
No, absolutely. I think one important aspect of this assessment report 6 is the high levels of confidence that are assigned to several of the assessments being made in the report. So climate science have, of course, strongly evolved since the pioneering days of Professor Manabe. And now we are having, of course, many ways to test these modeling systems. Remember, climate change has already occurred to date, so we can see if models can simulate these changes realistically. That's a test. These models are, of course, also being used to simulate paleoclimates. They are effectively very similar versions used for our daily weather forecast, for example. So the understanding of the science is evolving to the extent that we can now formulate, and this is the important point, what we call actionable messages for adaptation. So we have so much confidence in the findings that we can say the science is actionable. Based on the science, we can now not only formulate policy, but we can implement policy. Now, for Southern Africa, for example, it has been assessed all the way back since the 4th assessment report, at least back in 2007, that the region is likely to become generally drier and drastically warmer. That's what we call a robust message. We do not expect that further research will change the message. That's what robust means in our world. So it means South Africa or Southern Africa should prepare for that change. And that includes, for example, taking immediate action and preventing all these losses we are getting. For example, when we transport water in South Africa from the east in the mega dams towards Gauteng in the west. So if you know with certainty that the future is a drier future, why not take action? If we know the next 10 years will bring heat waves of an unprecedented intensity in Southern Africa, let's develop and implement heat health plans for our cities, including for everybody living in informal housing that are the most vulnerable. And let us strongly make our case to the international community in terms of leveraging adaptation funding for these projects that we need to protect the most vulnerable against the climate change impacts we know are coming in the near term. So yeah, no, I fully agree with Professor Galaz's assessment.
Yeah, you know, it wasn't so long ago, I think it must have been just over a week ago, that we heard disappointing news in South Africa. That essentially was the news that Eskom had now become the world's worst polluting power company in the world. I mean, that's not something to be very proud of as a country here in South Africa, especially considering all the challenges that Eskom then has. And then we get this question from Gavin Snow in the Q&A box. It says, Professor Engelbrach, South Africa is one of the top greenhouse gas contributors, but essentially demands international funding to reduce this. So what is top of your list to suggest to government to reduce emissions? Now, I want to add to that question and say, if we go into more granular details, Eskom has said that to reduce emissions, they need to make billions of investment in order to start switching over to renewable energy. It's an expensive exercise. where are the opportunities for South Africa? And perhaps there are lessons in Sweden as well, Professor Gelles, on where we've seen examples of transitions happening that have been successful, but where are those granular opportunities in South Africa, Professor Engelbrach, with power producing companies and that sort of thing?
Yeah, that's an exciting question, lady. I don't know how I will stop talking now that you've asked this, but let me just make a few points. This report you've just mentioned on Eskom is important. Let me just mention to the audience that it refers specifically to the sulfur dioxide emissions coming from Eskom. And I did check on this with South Africa's leading air quality experts at the time at CSIR and at Northwest University, because it was such a startling report. The report said Eskom as a company now emits more sulfur dioxide than the entire electricity sector in China. So of course that was a surprise, and I checked on that, but it seems to be true. And it's not because Eskom has increased its emissions. It's because in China, over the last 5 years or so, they have aggressively implemented technologies that capture sulfur dioxide before it is released into the atmosphere. So some members in the audience may know about the so-called scrubbing technologies. It was very expensive. But China has done that, and already in earlier years, this has been implemented, these technologies in the European Union, across the European Union, in the USA. And as a consequence of South Africa and Eskom not being able to implement these technologies because of the costs, our people are still suffering from these very high levels of pollutants, including now sulfur dioxide. That in some instances, of course, form small particles that are even more harmful to our health. So that's also a bit technical as part of the story. But the point is, it has been estimated that implementing these technologies across the 15 or so Eskom power plants will cost them in the order, or cost South Africa in the order of 200 billion rands. Now, the current debt load of Eskom, as I understand it, is in order of 400 billion rands. So that shows us, as South Africans, immediately we know what the problem is. There's a solution, but we're a developing country, and this specific company, of course, had a history of immense challenges, to put it softly. And now the solution is within our reach. We just can't afford it. Now, let's think about what it means in terms of future carbon dioxide emissions. South Africa has a critical role to play. We are responsible for just more than 1% of the world's emissions. It doesn't sound much, but here's another starting fact. If we add up the emissions coming from all the countries in the world that emit 1.5% of the world's carbon dioxide emissions or less, if we add up all those countries, we arrive at more than 30% of the world's emissions. And it means that even if China and the United States and the European Union and Japan and South Korea, all the big economies, with of course, almost 45% of the world's emissions sitting between the USA and China, even if they pursue strong climate change mitigation to their very best ability, we cannot prevent the most dangerous levels of global warming from being exceeded if all the smaller emitters are not also contributing fairly. So even the smaller economies and even the smaller emitters are needed collectively in order to reduce global warming and slow it down as quickly as we can. So the last thing I'll say is there are immense development opportunities for South Africa in being part of the solution. So if we are going to COP26 and we make a commitment and we say we will drastically reduce emissions, we are making this commitment to the international community. Of course, let's be realistic. We cannot do that without substantial investments and cheap loans coming to South Africa in terms of these just transition transactions that will convert our current dependency on coal into renewable energy, and also investments, also in infrastructure, in expensive infrastructure costs that we need investments for to adapt to climate change impacts. For example, the seawall at Beira in Mozambique. If that can be committed to credibly by the international community in return for South Africa enhancing its ambition in terms of greenhouse gas emissions, there's a path forward for South Africa, and the same is true for the other. The same can be true for the other developing countries across the world.
Professor Engelbrach, thanks for that. Professor Gallas, can I bring that question to you as well? Because essentially what I'm looking for here is, you know, here we talked about the more granular details of the challenges that we're experiencing with one organization here in South Africa. But I'm looking for the examples of where we have been able to see things turn around. Earlier in your presentation, you talked about how every time we've hit an economic slump globally, we've been able to reduce emissions, which is, you know, a really tough balancing act. But if we go to a micro level, have we been able to see organizations in Sweden or other parts of the world that have been able to cut their emissions, you know, significantly, and, you know, what we learned from those organizations?
I think if we look not only at organizations but also countries, I think it's difficult to separate. I mean, these are all interacting, right? Like the international discussions and the conference of the parties, national policies, and within that you have the business sectors, etc., trying to innovate. I think, of course, something that's getting a lot of attention here in Sweden and maybe also internationally is innovation around carbon-free steel or CO2 neutral steel, which could be a game changer. It's a massive investment, but could be a game changer internationally. I think this is all happening in a bigger context, and I think that context is important. I don't want to comment too much on the South African situation, but I think if you look at what is needed to stay within 1.5 to 2 degrees, that would mean keeping coal in the ground. I think we all know it. That's the most obvious policy thing that needs to be done. The International Energy Agency also says no more investments in oil and gas infrastructure from today, starting from today, not 2030. Those are very tangible things. Now, the challenge is, of course, is how do you set up a decision-making system that allows you to make those tough calls politically? And one of the innovations lately would be climate laws and independent government bodies that assess the policies of a government and look at how well does the government fulfill its ambitions to achieve climate targets. Right, so we have it here in Sweden, and I think the UK has the same. It doesn't transform everything at the same time immediately. That's not the point. The point is that you have an independent expert body that assesses government policy and opens up a discussion for actually how close are we to transform ambition to actual policy. And I think that's something that would be needed in many, many other countries as well. And that will create a push for innovation towards carbon neutrality and reduced carbon emissions.
We have a question from Martin de Witt that says, science is great in gaining insight through abstraction and analysis. Many people do not understand what it means and respond either with anxiety or fear to some level of or never-mindedness. That's an interesting point. Professor Gallas, how would you describe the characteristics of a climate strategy that is based on best science and is person-friendly? Martin, I think that's a wonderful question. I'm going to add to it as well, and I think Professor Engelbrach, if you can add to this as well. I've noted that what we do in this country is we talk about climate change, and it does to some extent feel like a very high-level discussion. That if you go down to the poorest of communities or some of the most vulnerable communities, that activism from the ground that you talked about, Victor Gallas, isn't necessarily there. And I wonder if the language that we're using isn't person-friendly, isn't accessible language when we talk about what is essentially a massive crisis that we're looking at here. I'll let you go first, Professor Gallas.
No, I think the narrative has to be prosperity, creating prosperity for people in a just way. I think that the messaging can't be you need to reduce your emissions now with 50% by the next decade. If you're talking to individuals, if you're talking to communities at risk, communities that need support across so many dimensions, the message should be our ambition is to create prosperity. And part of that prosperity is to help communities adapt to climate change, help reduce emissions to reduce risks in the future. I think that should certainly be the policy to do it. And I think different countries are approaching this in different ways. But we're not getting there, to be honest, really, in the messaging. We should be getting there, and we have to get there.
Yeah, I mean, we're struggling. It's a difficulty across the globe right now to find the right language to use to speak to communities. I mean, we're seeing it as well with the drive to try and get people vaccinated, you know, the back and forth on how to get people to access the information that they need. Is there a language change that we need to be looking at in South Africa, Professor Engelbrach?
Oh yes, Naledi, but once again, there is more happening, I think, than most people may think in this context. So this is a long-standing problem. Is of course, how do you convert these actionable messages of change? So the science is well evolved. So how do you convert that into climate change actions being taken? You know, within communities, within municipalities, all the way through to national government. So that has become a very special field of work across the world in the context of climate change adaptation, and also here in South Africa. For example, the institute where I work at, the Global Change Institute, is, for example, having a long-standing relationship and discussion with the city of Johannesburg in terms of climate change impacts. And over time, of course, one develops relationships of trust, and one starts to understand each other's language. And then gradually one embarks in what is known as a co-design process, where scientists and the actual decision makers over time jointly work out what the solutions are in terms of a specific, what the risks are, and then what the solutions are for a specific climate change threat to a city, for example, whether it is more flash flooding in relation to inadequate storm drainage, or whether it's more hailstorms impacting on informal housing, for example. So there are so many real-life problems that are already being tackled in South Africa, at least in some municipalities, through this wonderful co-design process between science and decision-making. Now, of course, I'm not saying that we have all of that. We need much more of that type of interaction. But I'll just mention one other positive example. South Africa, through its Department of Forestry and Fisheries and the Environment and the Climate Change Directorate, has had a very strong engagement with climate science in the country over the last, I would say, at least 10 years. And that engagement has resulted in South Africa's national adaptation strategy, directly informed by the country scientists. So there are positive things in South Africa. The government listens to scientists, if I can use COVID-19 language again. So it does listen to science and advice by scientists. I think, and at the municipal level, we are seeing implementations also happening. In terms of our national policy, in terms of mitigation, of course, we cannot deny that there is a lack of action. And the big hope is, of course, is that this can also be changed. And COP26 is going to be absolutely critical towards converting mitigation policy in South Africa into mitigation action.
Yeah. There's the point that's made that Sweden's carbon tax was introduced in 1991, ours only quite recently, and whether or not that sort of taxing and whipping, it actually works in getting people to change their behavior within the national context. But we're out of time, can you believe it? And that's quite unfortunate. Just as we wrap up, the eternal optimist in me would like to hear Professor Gallas, I'll give you about a minute just to give us your final thoughts, a call to action, perhaps, if you'd like to leave us with one. But I think more importantly, what you'll be up to next, so we can keep following some of the research that you'll be doing and keep learning from you.
Thank you. I mean, a challenge in 1 minute. I think, to me, the key messages are the following, and it will be a little bit of a repetition of what I said. I think we need to think about the climate crisis in the context of planetary change. So if we can bring together the climate challenge and biodiversity challenge, would be a major benefit. And that would all help us reduce not only climate risks, but also disease risks in the future. And then the second point being that actually mitigating climate change and adapting to climate change has massive benefits for people in terms of jobs, social welfare, better health systems, etc. I think to me, those would be the most important messages. Glasgow hopefully manages to accelerate action. We are just halfway through what we need to get done. So I'm really hoping for Glasgow to be that event when this accelerates.
Thank you, Professor Gallas. We're running over. Professor Engelbrach, please stick to that 1 minute.
Sure, I'll do my best. So what I would like to conclude with is by saying that every bit of global warming matters, and every bit of global warming we can still prevent from occurring will help us in terms of reduced impacts. So COP26 is of fundamental importance for Southern Africa as a climate change hotspot to be successful. We need to do two things. We need to realize that we are committed to further warming, and we must use climate change science to know what those risks are and adapt to these to the extent that we can. On the other hand, we must contribute our fair share to climate change mitigation. And in return for that, there can be immense opportunities for South Africa in terms of modernizing its economy, including building it into the future using renewable energy. On the other hand, if we do not do that, we will probably anyway be forced to do that under less favorable circumstances by the international community. So my prediction, I'll finish with that one, lady. I want to make a prediction now. I'm very positive about COP26. I think there's going to be a new international climate change pact, stronger than we've ever seen before. And investment will shift towards renewables across the world and in South Africa. Let's make use of that immense economic opportunity as South Africans over the next several years.
Well, thank you for leaving us with some positivity, Professor Engelbrach, because you started us on a very scary note there at the beginning of this webinar. But thank you so much for joining us. Thank you to Professor Francois Engelbrach, Professor of Climatology at the WITS Global Change Institute, as well as Professor Victor Gallas, Associate Professor in Political Science and also Deputy Director of the Stockholm Resilience Center. An absolute pleasure having both of you with us. The great thanks as well to the Swedish Embassy in Pretoria here in South Africa, as well as the National Research Foundation. This has been the 2021 Virtual Nobel-Inspired Lecture, Adapting to Change. What does the science say? Well, we've heard the answers. My name is Naledi Molewa. Keep talking, keep engaging with both organizations, and the conversation never ends because the work never does as well. Have yourselves a great afternoon.
Thank you, Naledi. Thanks, everybody. Goodbye.
Thank you.